Hello everyone, this is Miss Sassu and I'm going to be doing the video for this week. I hope you all are safe. I hope you all are doing well, and I hope you guys are keeping your head high during this tough time. If you guys need any assistance, feel free to reach out to any one of your teachers and we will try to assist you in any way that we can. Nonetheless, with this video, I do want to apologize in advance because it is going to be a low budget, bootleg, no technology style video, but I do promise you that you are going to still get the same skills, and by the end of this video you're going to be an expert at solving quadratic equations by factoring, and if not, please watch it twice. It's there for you. All right, so I'm going to go ahead and dig in here. So we're going to be using the same formula that we had last week with our standard form, ax squared plus bx plus c. The only difference here is that you're going to see it being set to equal 0, okay? So with it being set to equal 0, it's not an equation, and this is going to be an equation that we're going to be able to solve. And the method that we're using is factoring. So, number one, I have x squared minus 9x plus 18. I first want to start off by setting my A equal, B equal, and C equal. Also, let me say this. If you guys know that you aren't the best with factoring yet, we do have a video from last week that you may want to watch as a refresher, just to kind of remind yourself of certain things. But if not, feel free to continue listening. Okay, so my A is going to be 1, my B is going to be -9, and my C is going to be 18. So what I want to do now is multiply my A and my C, which gives me 18. So I'm looking for my two numbers that multiply to give me positive 18 and add to give me -9. So we talked about the table last week, so I'm going to go ahead and go on with the factors. The factors that I'll be looking for is going to be -6 and -3. You see, if I multiply those give me 18. And if I add those two together, I do get my -9. So from here, I'm going to go ahead and make my trinomial a 4-term polynomial. So I'm going to have x squared. My middle term is going to become -6x minus 3x. And then I'm going to bring down everything else. Okay, so let's act like this 0 is not here. If this 0 wasn't here, then I'll be doing the same steps that I did from last week. I would be grouping them together like so. And then from each group, I'm going to ask myself, what is the GCF? So my GCF out of x squared and -6x is going to be x. Okay, I'm going to go ahead and open my parentheses. X times what gives me x squared? That's going to be x. And x times what give me -6x? That's going to be -6. Okay, looking at the next set, my GCF is going to be -3. Okay, make sure that you take out that negative if this term right here is negative. Okay, so I'm going to go ahead and open my parentheses. So -3 times what will give me -3x? That's going to be x. And then -3 times what will give me 18? That's going to be -6. Still have that set to equal 0. Okay, so then from here, I see that these two are in common. So I can go ahead and bring that out. And then I'm going to bring down what was left, and that was x minus 3, which you can interchange these two. It doesn't matter what order that you put them in because it is multiplication. And then I still have this set to equal 0. So from here, if you remember the video from last week, we kind of stopped here and the answer looked something like this. So with this being set to equal 0, we're now going to talk about the zero product property. And what that says is that basically if I have two terms or two products that set to equal 0, I can set each one of them to equal 0 and I can solve. So I'm going to have x minus 6 equals 0. And I'm going to have x minus 3 equals 0. So from here, it's pretty much just going to be like me solving each equation. So I'm going to add 6 to both sides. I'm going to have x equals 6. And then here, I'm going to add 3 to both sides. and I'm going to have x equals 3. And that's it, okay? These are going to be your solutions. These are also your zeros and your roots. And if you was looking at it on a graph, these are going to be your x-intercepts. So keep that in mind. All right, so let's go ahead and move on. So number 2, I have n squared minus 64 equals 0. So from here, some of you probably notice that this is your difference of squares rule. Some of you are probably looking at this and you're saying, okay, I know I can square n squared and get n. I can square 64 and get 8. So my final answer will be n minus 8 and n plus 8, okay? But let me say this as well. The difference of squares is not for everybody, okay? If it's not your thing, then what I would recommend is you can expand this binomial to be a trinomial. So I'm going to have n squared plus 0n. I'm going to pretty much be using that as a placeholder. Minus 64 equals 0. So now I can work this out just like a normal trinomial. My a is going to be 1, my b is going to be 0, and my c is going to be negative 64. So I want my two numbers that multiply to give me negative 64, because my AC is negative 64. I want them to multiply to give me negative 64 and add to give me 0. Those two numbers are going to be negative 8 and positive 8. Okay, so now I'm going to rewrite. My middle term is going to become negative 8n plus 8n. And I'm going to bring down everything else. Okay, so from here, I'm going to group like so. My GCF here is n. On the inside, n times n will give me n squared. And n times negative 8 will give me negative 8n. My GCF here is going to be positive 8. I'm going to go ahead and take out that plus sign so when I put it together at the end, I do not get confused. So I'm going to have 8 times n will give me 8n. And I'm going to have 8 times negative 8 to give me negative 64. And that's still set to equal 0. So from here, I do have these two are the same. So I can go ahead and bring that out. And then I'm going to bring down my n plus 8 and set that to equal 0. From here, I'm going to apply my zero product property. So I'm going to have n minus 8 equals 0 and n plus 8 equals 0. I add 8 here. My first solution is n equals 8. And my second solution is n equals negative 8. Again, that's also where it's going to be crossing on your x-axis. All right, number 3. So as you see, number 3 looks a little bit different. The first thing you should notice is that, hey, this is not set to equal 0. So when you solve a quadratic equation by factoring, you first want to make sure that this is set to equal 0. So I'm going to subtract 7 from both sides. Okay, so I'm going to bring down k squared. Now here we have to make sure that we remember that these two are not like terms. So we're going to write them out separately like so. Okay, this cancels out here. So now I have my equal 0. So from here I can say A equal, B equal, C equal. A is 1, B is negative 6, C is negative 7. My AC will be negative 7. So I want two numbers that multiply to give me negative 7 and add to give me negative 6. Those numbers are going to be negative 7 and positive 1. Okay, so now I'm going to go ahead and rewrite. If you need to write in that 1, if it helps you, write it in. I'm going to go ahead and group this together like so. My GCF here is K. K times K will give me K squared because we know we add those exponents. K times Negative 7 will give me negative 7k. My GCF here is 1, so I'm going to bring out plus 1. Then 1 times k will give me k, and then 1 times negative 7 will give me 0. I'm going to bring down my factors. And then I'm going to go ahead and apply my zero product property. So I'm going to have k plus 1 equals 0 and k minus 7 equals 0. This first equation, I'm going to subtract 1 from both sides. I have k equals negative 1. And then here, I'm going to add 7 to both sides. So I have k equals 7. All right, number 4. So we have another one where it's not set to equal 0. So my first step, I'm going to add 72 to both sides. So I'm going to bring down the 6k squared. Again, these two are not like terms, so I'm going to bring down minus 42k plus 72. And these two cancel out, so now I have equals 0. So from here, I notice that I have a GCF this time. So if you look closely, you see that each one of these terms can be divided by 6. So I'm going to take out 6. 6 times k squared will give me 6k squared, so that's going to go on the inside. 6 times negative 7k will give me negative 42k, and 6 times 12 will give me 72, and that set to equal 0. So one thing I like to do is I like to act like this 6 is not here, and I'm just going to work it out like how I normally work out factoring a trinomial. So I'm going to have a equal, b equal, and c equal. So I have 1, negative 7, and 12. So my AC is going to be 12. So I'm looking for the two numbers that multiply to give me 12 and add to give me negative 7. Those are going to be negative 4 and negative 3. Okay, so I'm going to bring down a k squared. Again, I'm going to act like the 6 is not there, but I promise you we're not going to forget it at the end. My middle term is going to become negative 4k minus 3k, and then I'm going to bring down everything else. I'm going to group together my full-term polynomial. I'm going to have k as my GCF for this first group, okay, because we see we have a k there that we can take out. K times k will give me k squared. K times negative 4 will give me negative 4k. My next group, my GCF between these two is going to be negative 3. I'm going to open my parentheses. Negative 3 times k will give me negative 3k. And negative 3 times negative 4 will give me positive 12. So from here, I see that these two are the same. So I'm going to go ahead and bring that down. And then now I'm going to go ahead and bring down this 6. I didn't leave too much space for it, but it's okay. I'm just going to rewrite this. And I have my equal 0. So from here, I am ready to apply my zero product property. Now, I do have 3 factors here. So when I set this up, I'm also going to set this 6 to equal 0. And then I'm going to set the k minus 4 to equal 0, and then the k minus 3 to equal 0. So when I'm looking at this 6 equals 0, I'm really just going to ask myself, does 6 equal 0? That's untrue, so that is a false statement. So that's not going to be considered in our solution set. From here, when I'm looking at my k minus 4 equals 0, I'm going to add 4 to both sides. K equals 4. And then with this one, I'm going to add 3. K equals 3. All right. And that's number 4. All right. All right, number 5. So same thing with number 5. I do not have a GCF here. So I'm going to go ahead and define my A, B, and C. So I have 3, 14, and negative 49. My A times C is going to be negative 147. So I'm looking for the two numbers that multiply to give me negative 147, but then add to give me 14. Those numbers are going to be positive 21 and negative 7. Okay, so now, we rewrote. I'm going to go ahead and group my terms together. So my GCF here is going to be 3x. I'm going to open my parentheses. 3 times x will give me 3x squared. 3 times 7 will give me 21x. My next set, my GCF is going to be negative 7. X times negative 7 will give me negative 7x. And then negative 7 times positive 7 will give me negative 49. I'm going to set that to equal 0. These two are the same, so I'm going to go ahead and bring that out. I'm going to bring down what's left equals 0, and then I'm going to go ahead and apply my zero product property. So I have x plus 7 equals 0, and 3x minus 7 equals 0. On this equation, I'm going to subtract 7 from both sides. I have x equal negative 7. And on this equation, I'm going to add 7 first. Then I'm going to have 3x equals 7. Then I'm going to divide by 3. And I have x equals 7 over 3 as my second solution. All right, number 6. So first, I still want to make sure I set my equation to equal 0. So I'm going to subtract 6m from both sides. These cannot be combined. Even though they both have m, they both do not have the same degree. So I have to write 3m squared minus 6m, and then this cancels out. So now I have my equal 0. Okay, we have a greatest common factor here, which is 3m. So if I factor out my greatest common factor, on the inside, I'm going to have m because 3m times m give me 3m squared. And then 3m times negative 2 gives me 0. So as you see here, it looks a little different because I already have my two products set to equal 0. So I am ready to set or to apply my zero product property like so. So that's how that's going to look. This is product 1. This is product or factor 1. This is factor 2. So from here, I'm going to solve this equation. I'm going to divide 3 on both sides. I have m equals 0. And then here, I'm going to add 2 on both sides. I get m equals 2. All right. Now, these next two problems are going to be challenge problems. I encourage you to go ahead and watch them. They're not too bad. They're a little bit harder, but they're not too hard. So let's go. All right, so I have two terms that's on my right side, and I'm used to having my terms on the left side. So I'm just going to go ahead and move both of these to this left side. So I'm going to have plus 16m. So I'm going to add that. And then I'm going to just also line this plus 21 here up as well. So that way we can get our equation to look the way we want it to look. It looks a little sloppy here, but I promise it's going to all come together. So none of these are like terms. So from here, I want to go ahead and write 3m squared plus 16m plus 21. And then everything on this side cancels out. So I'm going to go ahead and I'm going to have my equal 0. So from here, I'm ready to set my A equal, B equal, and C equal, which I have 3, 16, and 21. And then from here, I'm looking for my two numbers that multiply to give me 63, which is my A times C, and add to give me 16. Those numbers are going to be 9 and 7. Okay, so now I'm going to go ahead and expand this. I have 3m squared. My middle is going to expand out to be 9m plus 7m plus 21 equals 0. I'm going to go ahead and group. My GCF here is 3m. On the inside, I'm going to have m because 3m times m give me 3m squared. And then I'm going to have 3 because 3m times 3 gives me 9m. Okay, this next set, my GCF is 7. 7 times m will give me 7m, and 7 times 3 will give me 21. 21. All right, so from here, those two are the same. So I have m plus 3, and then I'm going to bring down my 3m plus 7. Set that to equal 0. I'm ready to apply my zero product property, like so. I'm going to subtract 3 from both sides. M equals -3. And then here, I'm going to subtract 7 from both sides. I have 3m equal -7. Divide both sides by 3. M equals -7/3. Okay, so as I said, those were 2 challenge problems, and those weren't even that bad. So look at you. All right. All right, our last problem. So same thing, it's not quite set to equal 0. So I have -80p on the right side. I'm gonna add 80p to my left side as well. So one thing I'm gonna kind of do here, because when I have my standard form equation, I usually have my square term first, then my degree 1 term, and then my constant term. So when I put all this together, notice I'm gonna write 15p squared, but then this 80p that I have from the right side, I'm gonna go ahead and write that second. That way I have it in order of A, B, and C, okay? So I bring down my 80, this canceled out, so now I have my equal 0. So from here, we see we do have a GCF this time. That GCF is going to be 5 because 5 can divide into all 3 of these terms. So I'm going to have 5. On the inside, I'm going to have 3p squared because 5 times 3p squared gives us 15p squared. And then here, I'm going to have 16p. And then here, I'm going to have 16. And that equals 0. So again, when I factor out a term or a GCF in the beginning, I personally like to act like it's not there and then do the factoring like normal. So I have A is 3, B is 16, C is 16. When I multiply A and C, I get 48. So I'm looking for my 2 terms that multiply to give me 48, but add to give me 16. Those terms are going to be 4 and 12. Okay, so I'm going to go ahead and expand this out. I'm not going to forget about my 5. This is going to be plus 4p plus 12p plus 16 equals 0. I'm going to group this together like so. My GCF here is p. On my inside, I'm going to have 3p because p times 3p gives me 3p squared. Then next, I'm going to have plus 4 because p times 4 gives us 4p. And then my next part, my GCF, is going to be 4. So I'm going to have plus 4. 4 times 3p gives us 12p. And 4 times 4 gives us our 16. So that's going to be set to equal 0. These two are the same. So I'm going to have 3p plus 4. And then I'm going to bring down everything else. And let's not forget about our 5. Okay, so now I'm ready to apply my zero product property. I'm going to have 5 equals 0, 3p plus 4 equals 0, and then p plus 4 equals 0. Okay, so this is a false statement. That's not going to mean anything towards our solution set. This equation, I'm going to subtract 4 from both sides. I have 3p minus 4. Then I divide by 3. I get p equals -4/3. Okay, and then this next one, I'm going to subtract 4 from both sides. And I have p equals -4. All right. Let me scoot that down some so you can see. Sorry about that. All right, so that pretty much concludes our video. As I said in the beginning, if you have questions about anything, please feel free to reach out to one of your teachers and we can help you. Again, this is factoring quadratics using the factoring method.